Hello, my name's Craig Gallen, and today I want to talk to you about Scriptd, which is a very useful feature in OpenNMS which can help with integration. And the example I'm going to show you is in this repository. I'll provide it in the links, but it's a simple REST integration using the OpenNMS Scriptd capability. Now, before I do that, I just want to talk a little bit about Scriptd. And if you look in the OpenNMS examples folder in your system, it will be in executor examples. I'm showing you here the raw code in GitHub. Under examples, you will see that there is a Scriptd configuration and a Scriptd event forwarding bean shell script. If we look at the Scriptd configuration, you can see that it has a number of parts to it. It basically specifies what engine we're going to use, and in this case we're using bean shell, which is very like Java, but it's a scripted language. And under that we then have the start script, which is the thing that runs whenever this OpenNMS starts up. The stop script is what runs whenever OpenNMS closes down, and then the event script happens each time an event comes into OpenNMS. Every event will cause this global event script to run, but it's also possible to set it up. And if you look at the XSD for this file, you'll see that you can set it up so that only certain events will actually cause the event script to run. Now, in this particular example that is up on GitHub, we see that basically we are importing this Scriptd event forwarder file, and then we're actually running the forward event code which was in that file whenever that event comes in. And if we look briefly at the event script, which is this file here, we can see that what it's actually going to do is it's going to create an SNMP v1 trap of a particular OID, and then based on the information that's come in from the event, it will put that information into different OIDs or different var binds that will come out of a trap. So basically what this particular example is doing is it's taking an event from OpenNMS and turning it into a trap, which it fills up with event information, as you can see here in the script. So that's the example that's provided out of the box with OpenNMS. I'm going to show you an example that I have done, which is for sending information to a REST interface. And before I do that, it's actually quite useful to look at the code that actually runs Scriptd. So this is under the Scriptd folder within GitHub again, if you need to go and look for it. And you can see that basically the key file is this executor file. And if we click on that, we can see that it has methods, if we go down a little bit, for basically loading the config, then actually running the script itself, and execute events. So whenever an event happens, this is what actually gets exercised. And if we look at this in detail, if we just go down a little bit, we can see that the script manager registers a bean called node, which means that any script can find that node, and it will actually be the node that's been found from the node DAO within OpenNMS. And also it will allow us to find the event, and further down in this we'll see that we're able to find the event. Now what actually happens is that the script is exercised by the script manager on that event, and if there's a failure, then we log the failure. So worth looking at this executor code just to understand what's going on behind the scenes. But in our example, all we're doing is running the script. So let me show you my actual example, which is here on GitHub. Now, what I've got is a Docker Compose setup, which actually injects the configuration that we need. But also separately to that, I have a Road Fault API application, which is a Spring Boot application, and that actually provides me with something to send information to through the REST interface. Now, I won't go into detail how this little Road Fault API works, but I want to show you what it does. So if you run that road fault API, and to run it up, you first have to build it, and the instructions for building it are down here. And then you have to run it in Docker Compose. So if you run it in Docker Compose, this is what you will see. Essentially, you can send test messages, and the test messages will show up here. But if I stop that and start it again, and actually send my test message to it, so this is the road fault API road fault event. This is the event that I want to send. This is the REST API call, which I'm going to give. It's a post to service health, and it posts this information. If I send that, I get a reply saying everything is good. But if I look at the road fault API, you can see that I have actually created that information. This equipment reference message contact. Okay, so that is the information that I have received. If I send another one, I'll just actually clear all of this and then send it again. Send that, and you can see that this is a single message coming in. So that's a REST. To send it again, you can see there's a second one here. Okay, so that's what it does. So I'll just clear that message. There we go. And we have the OpenNMS web console here, and I'm going to look at the events in the web console, list of events here. But in this case now, what I want to do is I want to send an event to OpenNMS. I could use a number of different events, but I'm going to use this particular one, which is an alarm raise event. It's not something OpenNMS will recognize, but it will show up as an event. So if I send that into the OpenNMS REST API, and what I actually need to do is to set this up to an IPv6 address, because that's what's running on my machine, and just a little complicated. So there we go. So it's an IPv6 address. It's been accepted. And if I look at my events and look at it again, we can see that this new alarm raised event has been received by OpenNMS. Now that alarm raised event should now also generate within this particular little app. An alarm raised event has been received. So that's the event. If I just send this into OpenNMS again, and we should see a second one has been received. Okay, so that's all what we're trying to do. What we're trying to do is to post a REST event according to the format that this motorway fault API tester accepts. It will log the event and give us a little output of the event having come in. I can do it directly from the road fault API by posting this event, but if I post an event into OpenNMS called alarm raised, the OpenNMS Scriptd will send me another alarm coming in. And if I change the severity of the event to cleared, and send that, and then we should see another event that's come in, but in this case we've got alarm raised status value healthy, which corresponds to the cleared. Okay, so that's what it should look like. That's what it should do. So how does this work? Well, let's look at the actual script that I'm using. And as I said, I have a Docker Compose script which is running here. If I just look at the Docker Compose so you see what's in it. Basically, it's a standard OpenNMS with database and Horizon, and this road fault API is the actual little API application, which is running as also a Docker container. And then these are two camera simulators, which are basically SNMP agents that are sitting there and OpenNMS is listening for. Okay, so that's all I have running in my Docker Compose. Now, if I go back to the minimal horizon and I look at the configuration for it, under opt, under OpenNMS overlay, and under etc. This is what is being injected into the etc. directory of OpenNMS. Under imports, I've got this little test network, which is basically 3 nodes. So that's how I'm setting up the test network in OpenNMS. But also, I also have this Scriptd configuration and this particular bean shell that is being pulled in. So if I look at the Scriptd configuration, I should also point out that the log4j is here, and that log4j is set up so that bean shell should be set up for debug. Now let me just find this. I'll look for it here. So you can see in the log, I've set it up so I can do a debug and look at that data coming in. If I want to look at the Scriptd logs within the Docker container, I can do so. And I do that using yeah, bear with me. Okay, so if I am in the Docker Compose container, then I can do Docker Compose, exec open Horizon, bash. Now I'm in the OpenNMS container, and you can see under this I've got my logs, and Scriptd log is what I want to do. So what I'm going to do is follow that. So tail -f Scriptd log gives me basically all the logs that are executing within OpenNMS, and it's just going to follow that. So just to show you again, if I post this information in as an alarm raised, and I look at the logs, I should see that actually I've executed the script, and I'm sending the message out and I'm receiving the reply back. So that's the message that I'm sending out. So that's how you can see the logs, and that's how you can debug your code, by looking at Scriptd. But if I go back and actually look at the example itself, if we look at under integrations play, I'm going to show you this actual configuration again. And the Scriptd configuration for this basically is starting up by, effectively I've got a class here that I've created. Now it shows up this way in Bean Shell. There's a slight difference in how Bean Shell works between normal Java, but this is actually a class. And what this class does is it basically converts the OpenNMS severities into the severities that are important for this API. And this API has only got 4 severities to worry about. So we either return healthy, warning, faulty, or critical. And these are the severities in OpenNMS that it's taking in. So then under encode message, what I'm doing here is creating the JSON message that I want to send, and I'm filling it in with the values that I need. I have a little simple date formatter here that's going to generate the right time, but I'm basically using this information, source, equipment class, status, and everything else to create this message and to send out. Okay, and then under the rest of this, I'm just basically pulling in my scripted async client, which I'll talk about in a minute, and I am starting that client in order to be able to send out and receive messages. I need to stop the client at the end of everything, so that's what these things are doing, stopping the listener and stopping the client. And then under event script, we can see here that basically I'm checking what the event is. So I'll respond to alarm cleared and alarm raised and a notification alarm node up, node down. You can change this obviously to what you want. I'm putting out a little bit of information here in the debug log to say what event and what node. And remember, the node is injected and the event is injected. And then I am basically generating enough information to be able to create this JSON message, losing the sender utils, and I am posting a request out with the username and password and the JSON message. And that's basically all that I'm doing. Now, why am I using this asynchronous HTTP script? Well, the reason is that Scriptd is single-threaded, and so it expects you to come back very quickly from any calls that are made. And an HTTP request can take a long time, and there's no guarantee of how long it will take. So rather than synchronously making a call against an HTTP client, I'm using an async client so that I send the call and the message is fired, and we come back immediately to Scriptd, but the message will complete in its own time in its own thread and not hold everything else up. Now, what does that look like? Well, you can see here that I have imported this scripted client and I set several time ups. These are the timeouts for how long we wait for a reply, so maximum of 5 seconds, after which it'll just forget it. But if it does get a reply within 5 minutes, everything's fine. And then we have a listener, which is the listener for replies, and then starting the client itself, which is effectively starting up the thread pool to allow all of these separate requests to be sent. And at the end of it, we need to stop everything, so that's what's happening in the stop script. Now, what does the actual async API script look like? Well, let's have a look at that. And this may be useful for you if you want to do a similar sort of thing. This is the script here. And basically, again, it's Java. I'll work through it very quickly. We have this idea of a message handler for handling replies. So handle return message basically takes a JSON object, and in this case, it's just going to log it. But we could replace this message handler with a more complex return message handler, which we could inject into this script. But the async client itself is quite simple. Bound equals 20 basically is how many threads can we have running at a time. It's a maximum of 20. Timeout, maximum timeout in the message, 5 seconds. We have a linked blocking queue, which is used for replies. So every reply is sent into that queue, but the outgoing requests are all go out using the simple request client. The start listener here basically is listening for replies. Okay, so what we're doing is effectively handling an incoming message, and just effectively writing out the reply. That's what we're doing. So here we can see consume the message while true. Message comes in. It's taking the message off the queue, and it's sending it to the message listener. And if it's a poison message, which is basically how it all stops, then this thread stops. But all we're doing here is we're just listening for reply messages. This will become clear in a second. So we've got get requests, delete requests, post requests. These are the HTTP clients, and you can see that it's basically creating a get with the URL, and then it's executing the request. And if you go down to execute request, down at the bottom, we can see that what it's actually doing is it's creating a future callback, and it's basically this is what happens. The callback happens when it's completed, and when the message is completed, then it will effectively put that message on the queue, and will fail if it doesn't do anything. Okay, not really explaining that extremely well, but you get the idea. The idea is that this particular bit of code effectively sends a message out with a put or a patch or a get, and if there was a received reply coming back, it puts the reply on the queue, which can be read by something that's going to read it in an executor. Okay, so enough of this. You can obviously read your code at your leisure and try and get a bit better idea of it. Put very simply, we have a Scriptd which has got a certain amount of code in it for doing the mapping between the event and the message that needs to be sent out. We use this scripted sync client to actually send the message out, and we receive the events from OpenNMS, and on an event that we recognize, we generate the message, and down here we can see we post the message, and it's a post request, and that's sending the message out. And we're really not listening for replies in this case. We're just letting the replies go into the logs, as is the default for that handler. Okay, I don't know if this has been very well explained, but I'll perhaps do the video again later. But for now, hopefully that gives you an idea of how you can use Scriptd to do something reasonably complicated within OpenNMS. And it's also showing you how you can look at the logs and see what's going on as you run your script. Thank you very much, and goodbye.